The biology of aging is being demystified. We have the capacity to measure biological age in human beings with a precision that never existed before.
And if you're ready, we can begin.
We're not just looking at one metric of aging, but we're looking at many.
One of our major goals is to figure out ways to extend the health span of our species.
First, we're going to do an EKG that measures the electrical activity of your heart.
All right.
We would like to extend the duration of time during which people enjoy optimal health and optimal functional capacity.
We all know people that age more rapidly than others. They look older or they act older than their chronological age. We also know people on the other end of the spectrum, people that don't seem to age at all. So that tells us that there is a biology to aging and that it might be possible to move a person from one trajectory of aging to another.
That value.
The overall goal of the Human Longevity Laboratory is to discover ways to slow down the velocity of aging in people that are disadvantaged because of chronic conditions or circumstances.
Living with HIV and persons aging with HIV are an optimal model of accelerated aging. The things that we find in the accelerated aging that constitutes HIV are very much applicable and relevant for people without HIV, the general population.
We want to get a cross-sectional look at biological age from all walks of life in this city, from every zip code, from every socioeconomic group, from every ethnic group.
What we're going to do next is we're going to take this EKG and feed the information in this to an AI-based program that can see things that I can't see with the naked eye.
We use AI in several of the tests that we do that immediately give us a readout of your biological age.
Well, what we're going to be doing now is taking some photographs of your retina, okay? What the artificial intelligence models have done is they've taken a database of tens of thousands of individuals of varying different ages and genders and looked at the retinal images and run them through the models. They can then determine a retinal or bio age. We will be gathering information about retinal age and how it correlates to one's chronologic age, and then to tie that in to other organ systems. And then as our next step would be to see if there's any modifiable factors that we can intervene with or introduce that may help to slow down the aging process.
Philanthropy made all of this possible. Our very generous donor, John Potocsnak, charged us to do something in this space, and that's what we're going to accomplish. We have some big ideas about this. We want to clone this laboratory that we have here in Streeterville on every continent in the world. And we want to set up labs that are identical in terms of equipment, procedure, protocol, and together, a network like that can actually do something about the trajectory of aging